So in this video, I'm going to explain the next arithmetic instruction, which is called as a DCX. So DC means decrement. This DC means decrement and this X means register pair. So decrement register pair by 1. It means decrement the register pair content by 1, and after incrementing, store the content into that register pair itself. So here, for example, like first of all, we'll see their opcode. So opcode for this instruction is DCX, and as a operand, it will be same as like INX. So here also it is having register pair, and which register pair? That is BC register pair, which is denoted by B, DE register pair denoted by D, HL register pair denoted by H, and stack pointer register pair denoted by SP. So these four register pair are used along with this instruction as a DCX. Now we will understand their operation by taking this example here. So let's say, for example, if I am writing here DCX D. So here the function of this decrement this DE register pair content by 1, and after decrementing the result should be stored into this DE register pair itself. So here let's say, for example, if I am taking here the data of this DE as a 2000H. So now what will happen? We need to decrement this 2000H by 1, and then this result should be stored into where it should be stored. So this value will become 1FFH, and this should be stored into this DE register pair itself. So how it will happen? So first of all, this DE register pair content, we will take it here. So this DE content is 2000H, and in terms of binary, this will be retained as a 0010. Then again for the remaining, it will be 000, 000, and again here 000. Now here for this 0001H, we can write this in binary form as like this: 0000, then again 0000, again 0000, 001. So now we need to take the 2's complement of these values so that it is producing the representation of -1H. So here if we take 2's complement for this 16-bit, then this will become here as a 1. This is here 1 as a first non-zero, and remaining zeros will change to 1 itself. So now here these all bit will become here 1. So this should be added with this result here. So this is the representation of what? This is the representation of -0001H. So now if we will perform the addition of this, it means addition of this 2000H plus under bracket -0001H. So that is giving ultimately the decrement of this DE value by 1. So now here if we will do this operation, then what it will produce? 0 plus 1, it is here 1. So again here it is 1, 1, 1. Then again 0 plus 1 is 1, 0 plus 1 is 1, 0 plus 1 is 1, 0 plus 1 is 1. And at this stage 0 plus 1 is 1, 0 plus 1 is 1. Then here also 1, here also it is 1. At this stage 0 plus 1 it is 1. Then at this stage 1 plus 1 sum will be 0 and carry will be 1 here. So 1 plus 0 plus 1, again sum will be 0, carry will be 1. So again 1 plus 0 plus 1, sum will be 0 and carry will be 1. So if there is any carry, then this should be discarded here. This should be discarded here. So this will be called 1. Then it is F, then it is F, then this is also F here. So as a result of this, into the DE register pair. After the execution of this instruction, this DE register pair will have 1 triple FH. This is the value, or ultimately in this format we can show it here. This is D, this is E. So in this DE register pair, what it will store? 1F, and this is here FF. So this will be the value after execution of this instruction. And here also in INX or DCX also, increment or decrement, whatever it is happening, it is into the cyclic way, as like 0 to 1, again 1 to 2, 2 to 3, 3 to 0. So in the cyclic way it will happen. So even for the decrement also it will happen in this fashion, in this fashion. So increment or decrement or INX D6, these all will follow for the incrementing or decrementing this cyclic rotation only. So here also, by execution of this instruction, it is not going to alter any flag bits over there. So first of all, we'll see the rest of the part is the size, machine cycle, T state. So here, as like with respect to size, it is contains only English alphabet. So the size in terms of byte, it will be only 1 byte, because it is required only 1 byte as a opcode. And this opcode will be fetched from the memory to the processor. So it requires only 1 machine cycle, and that operation is called as a opcode fetch machine cycle. So rest of all the operations will be happening inside the processor during their execution time. And here, as like what I had explained for the INX, here also for the DCX also, for their opcode fetch operation, it will take here 6T state. So this is the very important point here for INX and DCX. Remember this, for INX, DCX, for the opcode fetch operation, it is required 6T states, because it is 16 bits of addition or subtraction here. So that is the reason for the execution. It is required somewhat more time compared to DCR. So in DCR we had seen that was taking 4 T states for the opcode fetch, but in the case of DCX it is taking 6 T states. And the another point, another key point is, as a note you can write down here, no flags are modified. No flags are modified. So it means it is not going to affect any flags, or simply we can say that no flags are affected. So this is the key point here we must have to note down. The first one is, as a register pair, it should be BC, DE, HL, SP, which is denoted by this. Second part is, for performing this subtraction, it is by default taking 2's complement method for the subtraction. It means decrementing this DE value by 1. Then the next point is, the after decrement operation, whatever the result it is obtained, it is going to be stored into the same register pair. Then the next point is, for the opcode fetch, it will take 60 states. Then the last point is, with respect to flags, no flags are altered or modified after execution of this instruction. So what are the status of the flags before execution of this instruction? It will be carried forward same, or it will be same, and here no flags are modified. I hope you understand this instruction in the better way, and you can compare this DCX with the DCR. You can compare this DCX with the INX also, like that, and how we are getting their size in terms of byte, machine cycle, T states. These all the things I had given with much of clarity. So I hope you understand this instruction in the better way. Thank you.